Hi class, back again. We have one last little thing we need to talk about before we're done with set theory, and that is interval vectors, right? And interval vectors. And if we look at this, there's not a lot to them, but we need to be careful about how we analyze interval vectors. And what we have to understand is that there are only 6 intervals. Only 6, right? Because of our rule of 9. If I give you a major 7th, no, that inverts to a major 2nd. So anything higher than a tritone, which inverts to itself, is inverted back down to something smaller. So we have 6 interval vectors: a minor 2nd, a major 2nd, a minor 3rd, a major 3rd, a perfect 4th, and a tritone. There are 6 interval vectors, right? 6 interval vectors that we can possibly do. So let's go back to our pretty handy little pitch class set of G, G sharp, and B, right? Before we go do that, it's really good to write a dashed line under these because we're going to count how many intervals we have, right? So, what I do is I start with this note. G to G sharp is what kind of interval? Well, it's a minor 2nd. So put a tally down here for a minor 2nd. Let's flip back over. G to B is what kind of interval? A major 3rd. Put a tally down here for a major 3rd. Are those all the intervals? No. G sharp to B is what kind of interval? It's a minor 3rd. No other intervals? Your interval vector is 1, 0, 1, 1, 0, 0. Meaning 1 minor 2nd, 1 minor 3rd, and 1 major 3rd is present in this pitch class set. Make sense? Hopefully. Let's do another one. Let's do a few more examples. Let's just pull some random numbers, okay? Random notes, I should say. See, I'm already getting all mixed up. Ooh, we're not going to do 4 yet. We'll do 3. Even though this is not in prime form or normal order, I'm doing this to show an example. I have A, B flat, and G written down. So, let's figure this out. A to B flat. Now, you would never have something like this, right? You would put this in normal order, which would be G, A, and B flat, right? That's what you would do, okay? So, A to B flat is what kind of an interval? It's a minor 2nd. Oops, my lines are getting. It's a minor 2nd. Put a tally there. A to G is what kind of an interval? What's a minor 7th, right? Minor 7th inverts to what? Major 2nd. Now, B flat to G is what kind of interval? That's right, it's a major 6th, major 6th. So a major 6 inverts to what? Minor 3rd, right? So let's take this and put it into a normal order, right? G, A, B flat, right? Let's see if this interval vector still holds true. We had 1, 1, 1, 0, 0, 0. Okay. G to A, major 2nd. Boom. Major 2nd. G to B flat, minor 3rd. Boom. Starting to line up. A to B flat, minor 2nd. Looks like that holds true. 0, 0, 0. Okay? So, that's interval vectors. Real quick though, let's do one with 4 notes in it. I'll be kind and I'll do a normal order. Okay? So we have F, G, A flat, B flat. Okay? Let's start out. F to G is what? A major second. Put a tally down. F to A flat, minor third. Put a tally down. F to B flat, perfect fourth. Put a tally down. Now start on G, because you've already gone from F to G, so now start on G and relate to all these. G to A flat is what? A minor second. Okay. G to B flat is what? A minor third. Put a tally down. So you've done F in all these notes, G in all these notes. Now we need to do A flat in all of these notes. A flat to B flat is what? It's a major second. So we do the tallies. We go 1, 2, 2, 0, 1, 0. There's our interval vector. Of this pitch set, right? Which if we wanted to write out the actual numbers, and this seems to be in normal order, F is what? F is 5, G is 7, A flat would there be, oh, what am I messing up with? Well, B flat's 10, so that must be 8. Well, there we go. There is our pitch class. In normal order too. Hey, let's do something a little bit interesting. Now that we've found the interval vector, 1, 2, 2, 0, 1, 0, let's write that up here. 1, 2, 2, 0, 1, 0. There's our interval vector, right? We found our normal order. Let's try to find our prime form. 5, let's do minus 5. That'll get us down to 0, right? 7 minus 5 is what? 2. 8 minus 5 is 3. 10 minus 5 is 5. We need to check the inversion though, right? Check the inversion. So invert this normal order, right? 5 then becomes what? 7. 7 becomes 5. 8 plus what equals 4. 10 becomes 2. Put it in normal order, that becomes 2, 4, 5, 7. Right? So I inverted this. 5 plus what equals 12? 7. 5, 4, 2. Do that. Right? You seeing this? Then I reversed it, so I put it in normal order. Now I need to get it down to prime form. So if I just added 10, or I could subtract 2. Either way, 12. Subtract 2, that's 0. Subtract 2 would be 2. Subtract 2 would be 3, subtract 2 would be 5. Oh, interesting. Very, very interesting. It's non-inversionable. Hey! Ha. Oh, isn't that interesting? Inversionally symmetrical set. Let's look up the Forte number. So we know that the interval vector is 1, 2, 2, 0, 1, 0. We know that the normal order is 5, 7, 8, 1, and the prime form, regardless of whether we invert it or not, is 0, 2, 3, 5. Let's look up the Forte number. It's a tetrachord, right? So 4. So let's flip in our book to page, I think it was page 559. Appendix C, yeah. There's trichords, non-accords, tetrachords. Here we are. And we said it was what? 1, 2, 3, 0. 0, 2, 3, 5. 0, 2, 3, 5. Yeah. Yeah. 0, 2, 3, 5. Yep. Here we are. 0, 2, 3, 5. Forte number. This is page 60. A little bit down on tetrachords. 4-10. 0, 2, 3, 5. Yep, did we get the interval vector correct? Follow along. 1, 2, 1. Oh, excuse me. 1, 2, 2, 0, 1, 0. 1, 2, 2, 0, 1, 0. Yes, we followed and did everything correct. So good for us, and we found an inversionally symmetrical set. Pretty cool, right? Okay, so that pretty much ends pitch set theory. That ends pitch set theory, guys. Congratulations. We are finished. But that's only 1/3 of the chapter, so get ready because we're going into 12-tone serialism next. And I need you to print off some 12 by 12 matrices in order for us to complete this. Okay? So, till next time, class. Take care.